Organic lab. Let's do a Claisen condensation. And these are the components that we can utilize. I'm going to place, by double-clicking methyl acetate in the round bottom. You can see it on the blackboard. And I'm going to place in there, propyl methyl propanoate. So we're going to do Claisen, a mixed Claisen. Both are activated, have alpha hydrogens, alpha carbon hydrogens. So we're going to be getting more than one product here. Now let's put a solvent in there, ethanol. And you can see there are the three components. Bring it down to the stir plate. I'm going to need a catalyst. So I am going to offer it sodium methoxide. Double click. And make sure we get that in there. Okay. There are the components. And sodium methoxide catalyst, a base catalyzed Claisen condensation. We're going to need a heater and a reflux condenser, nitrogen gas, and we're underway. Note the time on the clock. Let's do a TLC at time 0. There's a notebook up there. We can record that. And we can see we're already getting reaction from the TLC. And over there are the components, reactants, products. Let's move the clock up 10 minutes. Do a TLC. And we're seeing changes there. Let's move up that amount of time. Do a TLC. You can see the changes occurring. We have a pretty hefty mixture, right? We're going to get 4 products, a self-Claisen times 2 and a mixed Claisen times 2. So, okay. Let me let it go an hour. Check again. And that's remaining pretty constant now. So, what we'll do, and you can record this in the notebook, you know. And I'll tell it to save the TLC. And I'll click OK. Now, if you open up that notebook, there it is. And you can see that TLC. Exit out. Okay, what do we do now? We have to do a workup. So what we're going to do is get the SEP funnel. Terminates the reaction. And we used a base catalyst, sodium methoxide. So we're going to have to use aqueous acid in the workup to neutralize that. Let's check the layers. Top layer, organic components. Bottom layer, sodium chloride and water. So we need that top layer, and we're going to L-drag it over to this round bottom. And we're going to now presume we've dried it, and we're going to set up distillation. So I'm going to bring the round bottom back up to the stir plate. The SEP funnel disappears. Let's hook up the condenser for distillation. And nitrogen gas. And we'll start heating. Note the time on the clock. Right now we have these components. Let's see our temperature. 25 degrees. Nothing in the collection flask. Let's go up 10 minutes. And temperature 156. We're getting action. Look on the blackboard, you can see one of the Claisen products. Temperatures at 156. These are the components that are on the blackboard are still in the round bottom in the pot. And we're up to 156. Let me go up 10 minutes. We got rid of the ethanol when we did the workup with aqueous acid. And in our collection pot, we still have one product. Go up 10 minutes, maybe 20. And the collection pot, we still have one product clean coming over. And holding steady at 156 Celsius. Let's go up an hour. Let's check. And you see now, we're getting 3 of the 4 possible Claisen esters forming. And what temperature are we at? We're up to 170. There's the pot mixture. There's the collection flask. Eventually, when the reaction is done, when we're done distilling, it will, of course, shut down. But let's go up 10 minutes. 177. 3 products. Four products. We're at 177 Celsius, and we have 4 products. And we expect 4. Okay, what I'm going to do at this point is hold down L drag. I'm using a Mac. And there are the 4 products. And we can do, of course, a complex mixture. What we can do is maybe try an FTIR. Okay. And of course we can just look at the ethyl acetoacetate. There's the other product, the second, the third, and the fourth. So I'm not going to do proton NMR or C13. Do you see I just changed it to C13. We're not going to do that, or mass spec. You can even do melting points with solids. But you get a rough idea how this works. Let me go up another hour. And 4 products, and we still have material there, and we're at 190 degrees. I'm going to go up again. And it's done. So you see they use rate constants from the literature for, in this case, Claisen condensations. So there's beautiful sync between the reaction time, if you let it go, or you can expedite, you can move it up, you see, depending on the amount of time you want to put in. But it's an excellent, excellent program put out by chemistry professors at Brigham Young University. It's commercially available. $25 an annual license fee for students for Mac or PC, and excellent value for the price. You can do organic structure determination, but we'll do that in another video. Thanks for watching. Bye for now.